All right, day 3, matrix multiplication. A little bit different than it is adding and subtracting, because you can't just add or subtract the common numbers or the numbers that have the same address. When you're doing matrix multiplication, first of all, you have to see if you can actually multiply the two matrices. Now, with adding and subtracting, they had to have the same dimensions. But with multiplication, it doesn't work that way. When you're doing multiplication, here's the rule. The number of columns in the first matrix have to equal the number of rows in the second matrix. Now, what I mean by that is if you are multiplying, let's say, a 2 by 2 times a 2 by 2, then you're okay. All right? So when I say number of columns, we're talking about its dimensions. So let's say, for example, that matrix A was a 2 by 3 and matrix B was a 3 by 5. Now, if I want to do A times B, then I need to check to make sure I can multiply that. So what I would do is I would say, okay, matrix A is a 2 by 3 and matrix B is a 3 by 5. So what I'm looking for is the number of columns in the first matrix, because remember we do rows by columns, has to equal the number of rows in the second matrix. Now the easiest way to do this is just write the dimensions right next to each other and then see if the two inside numbers are the same. Now you do have to write them in the order that they appear. So let's switch this around. Let's say that we decided to do matrix B times matrix A. So now I would say, okay, it's a 3 by 5, that's matrix B, and matrix A is a 2 by 3. So now if we look at this, the columns in the first matrix do not equal the rows in the second matrix. So you cannot multiply these. All right? So the first thing you have to check is if you can actually multiply them. Okay, so when we do matrix multiplication, here's what we do. We take the rows in the first matrix and we multiply them by the columns in the second matrix. I know that sounds really, really weird. You're like, what in the world? So when you do matrix multiplication, your first matrix, you're only going to work with the rows, and in the second matrix, you're only going to work with the columns. Okay? So let's take a look at a few examples here. So matrix A is going to be a 2 by 2, negative 1, 0, 5, 2. Let's make matrix B a 2 by 2 as well. And then let's make matrix C, let's make it a 2 by 4. Okay. Now one thing I forgot to mention, if you can multiply these matrices, like here with this one we can multiply it, my answer will actually come out to be the numbers that are on the outside. So if I multiplied here 2 by 3 times 3 by 5, my answer would come out to be a 2 by 5. But I'll show you that in just a minute. So let's just start out here and let's just do matrix A times matrix B. So matrix A, negative 1, 0, 5, 2, times matrix B, which is 3, 4, negative 2, 5. Okay? So first of all, let's check and see if we can actually multiply these out. So I have a 2 by 2, and a 2 by 2, and the inside numbers are the same. So I can actually do this one. And then, if you look at my outside numbers, that's going to be the dimensions of my answer. So my solution will be a 2 by 2 here. Okay? Now, let me show you how to multiply these out. A little bit tricky here. Okay? All right, so when we go to multiply this out, what we're going to do is in the first matrix here, we're only going to deal with rows. So we're going to look at rows going in that direction. And in the second matrix, we're only going to deal with the columns. Okay? Now here's the way we do this. So I'm going to start off and I'm going to go -1 times 3. So I've got -1 times 3. And then I'm going to work across here. So I'm going to move across to the 0. And here I'm going to move down. So I'm going to do -1 times 3. And then I'm going to do 0 times -2. And I'm going to add that to get my first number there in my matrix. Alright? That's a little tricky there. So I went -1 times 3, 0 times -2. So I went across here and I went down here. Okay? Now, when you look at this, this is row 1, that's column 1. This answer is row 1, column 1. Okay? Now, let's go ahead and let's do the second row here. So I'm still going to use row 1 here, but now I'm going to move over to the second column. So I'm going to go -1 times 4, plus I'm going to move across here to 0, and I'm going to move down here to the 5, 0 times 5. All right? Now, here again, this is row 1, this is column 2. This answer will be row 1, column 2. Okay? So let's just keep moving on here. So now we've used row 1, so now let's go to row 2. We're going to go 5 times 3. And again, we're going to move across here to the 2. We're going to move down here to the -2. So we go 2 times -2. And then here, we're going to use the second column now. We're going to go 5 times 4. And then we're moving across here and down. We do 2 times the 5. Okay? Now, to get my final answer, what I need to do is really just clean all this up, and I'll have my answer. So -1 times 3 is -3, plus 0 times -2 is 0, so that's going to give me -3 there. -1 times 4 is 4, 0 times 5 is 0, so that's going to give me -4. 5 times 3 is 15, 2 times -2 is -4, 15 plus -4 is 11, and 5 times 4 is 20, 2 times 5 is 10, when you add those up you get 30. And this is my solution when I multiply them. Okay, so if you look at that, you'll notice I do have a 2 by 2, which is what I should have ended up with. Okay, that's matrix multiplication. All right, so let me do one more here, just to give you another example. Let's do A times C now. Okay, so take matrix A, -1, 0, 5, 2. But now matrix C was a 2 by 4, remember? So we'll write that down. So let's make sure that we can do this here. Let's see, we've got what, a 2 by 2 and a 2 by 4. My inside numbers are the same, so I'm good. And then remember, those will be my solution, which will be a 2 by 4. Okay? So now, when I do this one, I'm going to write it down here. I'm going to move my paper down a little bit because I need a little bit of space. So let's see here. All right, so we're going to go rows here. We're going columns here. Okay? So what I'm going to do is I'm going to use row 1, and I'm going to multiply it by every column here. And that's going to be row 1 across here. So when I do this, I'm going to go -1 times 1. All right, and then as I move across, I'm going to the 0 and I'm going to the 6. So 0 times 6. Row 1, column 1. And now let's do row 1, column 2. So -1 times 0, move across, 0 times 13. Let's go to row 3. -1 times 3, 0 times 10. And then let's go to the last column here. -1 times -2. And 0 times -8. All right. Now notice, row 1, that's all I used here. That's all I have here is row 1. So now let's do row 2. So now we're going to do each column again, but now we're only going to use row 2. So we go 5 times 1 plus 2 times 6. So I went 5 times 1, then 2 times 6. Now I'm going to go 5 times 0, 2 times 13, 5 times 3, 2 times 10, 5 times negative 2, 2 times negative 8. Now, if you notice here, notice that in the parentheses I have all the same numbers in each column, and these are my numbers that are in my columns here. Okay, so now we'll just work this out. So let's see. Negative 1 times 1 is negative 1, plus 0, that's just going to be negative 1. Negative 1 times 0, plus 0 times 13, that's going to be 0. Here, let's see, negative 3 plus 0 is negative 3, and here we end up with positive 2. And then here, let's see, we get 5 plus 12, which is what, 17. Here we get 0 plus 26, that's 26. 15 plus 20, let's see, what's that, 35. And then here, negative 10 and negative 16 is negative 26. And that is my final answer. All right, so we'll talk more about this in class tomorrow. Make sure it's multiplication.